because the impression that you get from reading that is that these things are absolutely horrendous, and they are something that, it's kind of like if this were actually true, I should not be here talking to you right now, because I have worked with these materials, and I've worked with them at concentrations that are probably anywhere from 1 million to 1 billion times greater than anything any of you will ever come in contact with, even if you're eating all the so-called contaminated fish in the ocean. So in terms of the actual toxicity of these materials, they are toxic. There's no question about that. But when we talk about toxicity, we have to put that into perspective. And when it says it causes cancer in animals or immune there's certain immune dysfunctions that occur, but then when it adds to human beings, I've actually got a study that was done that I want to talk to you about. It was a study that was done from individuals who survived what was probably the worst dioxin exposure in history. So this was an explosion that occurred at a plant in Seveso, Italy. And it was in 1976, I believe. Yes, it was 1976. And after that explosion, there were, I guess, there must have been several thousand people that lived in that area. I don't really know. I don't actually have a total number of people that were investigated, although it does talk about hundreds of cases of certain kind of a certain kind of condition. And the only human effect the only effect of something like this, of tetrachlorodibenzodioxin on human beings, that is absolutely certainly attributable to that compound and compounds like it, is a very unusual skin condition called chloracne. It's a very, very severe kind of acne. It causes open lesions on the skin. It can be very disfiguring. However, it does clear up when you move away, or you after a period of time, when you're out of these materials ultimately are metabolized by the body. Now, they have a long half-life. It takes a long period of time for them to be completely metabolized. But after a while, people that are exposed to this, or have been exposed to this chloracne actually does clear up. So the chloracne in Seveso. And in Seveso, how much dioxin was actually found? Well, they divided the area up into into 3 zones, which they called zones A, B, and R. The R zone, which was the furthest point from the explosion, where they were still getting detectable amounts of dioxins, were at levels of 1.5 micrograms. That's a millionth of a gram per square meter of ground. So that's really, a square meter is pretty big. It's a meter's larger than a yard. So this is more than a square yard of material, and you've got a total concentration of these materials of 1.5 millionths of a gram. In zone B, the concentrations went up to 5 micrograms, as high as 5 micrograms per square meter, and in zone A, they were anywhere from, I believe, 15 micrograms at the lowest, up to as high as 580 micrograms per square meter. So at 580 micrograms, now you're talking about a little bit more than a half of a milligram per square meter. What does a half a milligram look like? Well, think about an aspirin tablet. An aspirin tablet is about a half a gram, roughly, 500 milligrams. And they're talking about a half a milligram. So this would be something approximately 1,000th the size of an aspirin tablet. And then you're going to distribute that over an area of land that is, like I said, an area of land that's a square meter. So it's not, even that is not a terribly high concentration. But having worked in this industry for many, many years, I was told at one point in time that part of my job was to develop a procedure for actually getting rid of these materials. And we in the laboratory used to refer to these as political poisons, because they the actual toxicity of these things was such that, yeah, we identified them as toxins, but we all thought that too much effort was being put on trying to eliminate these things from the environment. So I have 3 U.S. patents for processes that I developed to actually destroy these kinds of things, PCBs, dioxins, and dibenzofurans. And one of them was actually used at a Superfund site. These were sites that were designated by the federal government to be highly contaminated. A Superfund was set up that actually had to do with fines that were imposed on companies like Monsanto and other companies that were said to be polluting the environment. And this fund, which was a multi-billion-dollar fund, money from that fund was used to remediate some of the contaminated areas. So there was an area in North Dartmouth, Massachusetts, and this would have been back in the sometime in the 1980s. I don't remember exactly when, but I spent several weeks out there watching my process being used to decontaminate the soil from PCBs, etc., that were actually placed on that site. And this was a $16.3 million job that the company got as a result of the work that I was doing. So, they were very, very happy about that, and we were able to reduce the PCBs and dioxins down to very, very low levels. I mean, we're talking about with PCBs starting out at levels that were up in the hundreds of thousands of parts per million, down to 10 parts per million or less in most cases. So again, there are chemical ways of dealing with these things. However, if these materials are in the water, it's a little bit more difficult than getting them when they're in soil, and especially when they're at such low concentrations and they've already entered the food chain, that they're already in fish or other organisms that are in the water. That's a lot harder to really deal with that. But I do want to look at the claim that's made in the book about the toxicity of these materials, and I want to deal with particularly with 2,3,7,8 tetrachlorodibenzodioxin, which is usually described as being the most toxic of all of the PCBD congeners. It's more toxic than any of the PCDFs, and certainly more toxic than any of the polychlorinated biphenyls. So that's the one I want to talk about. And I've got LD50s, which are actually experimentally determined kind of lethal, what are known as lethal doses. It's a lethal dose that will kill 50% of a test group. So, and you have to look at the various animals that are involved in here. And of course, human beings are not involved because we don't do these kinds of studies on human beings. Who did these kinds of studies? Nazis would have done these kinds of studies, because you don't use a human as a test subject. So, in particular, what we're doing is we're actually looking at the concentrations of these materials in rat, mouse, monkey, rabbit, hamster, guinea pig, and dog. And for instance, in the rat, the LD50 is 22 to 100 micrograms per kilogram, and this is an orally administered dose. 70 micrograms per kilogram for the mouse, 114 to 280 micrograms. That kind of a range probably implies that there were different studies that were done, so it's somewhere in the few hundred micrograms per kilogram. That's per kilogram of body weight. So we're saying, if we say for instance 1,000 micrograms per kilogram, what we would be saying in 1 kilogram of body weight, we would be 1,000 micrograms, which would be a milligram. That would actually be 1 part per million of body weight. The rabbit, it was much more toxic in the rabbit, 10 micrograms per kilogram. In the hamster, 1,160 to 5,000 micrograms per kilogram. That's 5 milligrams per kilogram, and that's toxic, but it's not enormously toxic. The dog was 30 to 300 micrograms, and the guinea pig, which is what really started a lot of this fuss, the guinea pig is the most susceptible animal. Guinea pigs die at concentrations of as low as 0.5 micrograms per kilogram, a half a microgram. So that's 500 nanograms, 500 billionths of a gram per kilogram. We used to joke that if you actually showed the chemical structure of this compound to a guinea pig, it would die from fright. Guinea pigs are extraordinarily susceptible. How does all this translate into human health? So when the book says it makes this statement about animals and humans, the point is that I've shown you just with 3, 4, 7 different animals an enormous response rate. In one case, just going from the guinea pig to the hamster, guinea pigs are 1/2 of a microgram, and hamsters are 5,000 micrograms. So you're talking about something on the order of 4 orders of magnitude difference in concentration. In other words, what that's saying is that a hamster could survive 10,000 times the dose that would actually kill a guinea pig. And because of all these differences that we get among species, it's very, very hard in that case to extrapolate from these animal studies to human studies, to human beings rather. We don't do human studies, but to extrapolate from the animal case to human beings. So what we have to do in that case is to look at an actual accident, the one that occurred in Seveso, Italy, for instance, where there was this kind of contamination, and there were 2,3,7,8 tetrachlorodibenzodioxin that was scattered over a fairly wide area. We know that there were human beings that were involved in this because, according to this study that was done 15 years actually after the incident occurred, an epidemiological study, a study to show what the long-term effects of these materials were, that they found that there were something on the order of 200 or maybe slightly more than 200 cases of chloracne in Zone 1. And most of those were children. So maybe children are somewhat more susceptible than adults are. But that was of the total exposed population. That was the number of incidents of chloracne. And let me see if I can find some of the other things. People complained right after this accident. First of all, they found that vegetation, birds, and courtyard animals were seriously affected. People happened to be on the deposition path of the cloud, developed nausea, headache, and eye irritation, and a few children were admitted to the local community hospitals for skin lesions on exposed parts of the body. That would be the chloracne. The presence of TCDD as the main component of the toxic cloud was made known 10 days after the accident, and the estimate of how much of this material was actually released into the atmosphere, or it was actually released into the environment, was anywhere from a few hundred grams, so at the low end, all the way up to 34 kilograms. So nobody really knows how much of this stuff was released. Where did it come from? They were probably making this compound, which is up until that time was used to make a herbicide, which is no longer available. But the compound is it's a phenol. This is phenol, and it was actually this particular phenol, which is called 2,4,5. Let me see, did I do this right? I want to make sure I got the right phenol here. Yeah, this is 2,4,5 trichlorophenol. And this material, when it's heated up, especially in the presence of base, will self-condense. It will condense with another molecule of itself, eliminate hydrochloric acid, and form this material right here. So this was actually used to make a herbicide, which is called 2,4,5-T. By the way, those of you that remember something called Agent Orange, that was used to as a defoliative material in Vietnam. This is the herbicide, 2,4,5 trichlorophenoxyacetic acid. and just call 245T for short, this is what a whole bunch of people came back from Vietnam and claimed that they had these long-term health defects, and they were claiming that it was because this material was present in the herbicide, in the